Hello and welcome to today's lesson on distance, time and speed. Our learning objectives are to describe how to measure distance and time across a range of scenarios and then use those measurements of distance and time to calculate speeds. Also make calculations using ratios to convert from one type of unit to another. Apply formulae relating distance, time and speed for uniform motion and calculate average speed for non-uniform motion. In order to calculate the speed of an object, you need to know two things. The first is the distance that it's travelling, and the second is how long it took to travel that distance. If we have the distance and time taken, we can find the speed using the equation shown here, where average speed is total distance divided by total time, or speed is distance over time. You may want to pause the video here and copy that down in your books. Using the equation speed is distance divided by time, calculate the speed of the car in kilometres per hour. Pause the video now while you do the calculation. A distance of 60 kilometres divided by a time of 2 hours gives us 60 divided by 2, so 30 kilometres per hour. Now we have a balloon travelling 30 kilometres in 10 hours. How fast is the balloon moving and what units would that be in? Don't forget to pause the video. So it would be 30 divided by 10, giving us 3. And because we were given the distance in kilometres and the time in hours, the units would be kilometres per hour. Now we have a boat travelling 60 miles in 20 hours. What would its average speed be? Once again, think about the units that you're going to use for its speed. "60 divided by 20 will give a speed of 3 miles per hour because our distance is in miles and our time is in hours. Now we have a chicken travelling 30 metres in 10 seconds. How fast would that chicken be travelling and what would the units be? Pause the video while you work it out. So 30 divided by 10 would give a speed of 3 and the units is metres divided by seconds, metres per second. Here we have a dog travelling 600 metres in 1 minute. You need to find its average speed, but watch out, you need to give the answer in metres per second, but you've been given the time in minutes. So your first step is to change it into base units, so change the minutes into seconds. So it would be 600 metres divided by 60 seconds, giving an answer of 10 metres per second. If you're doing an experiment to find the speed of an object, then the first thing that you need to be able to do is measure the distance. Now, if it's a relatively short distance, then using a ruler would be fine, as you can see here at the bottom of the page. If it's a longer distance, then you're probably going to want to use a tape measure. An example of one is on the right-hand side. If it's an even longer distance, then we might use something called a trundle wheel, and you can see a picture of one of those on the left. Finally, if we wanted to take lots of readings, we could use something called an ultrasonic distance sensor, and there's a picture of one of those here in the center of the page. Hopefully we'll get to try one of those in class. Measuring time tends to be a lot simpler. Normally we'll use a stopwatch, as you can see here on the left hand side, but you may also get a chance to use something called light gates. It's important that you remember that light gates are a method of measuring time and not distance. You're now going to get a chance to try and measure the speed of 4 different objects. We're also going to look at the repeatability of the experiment, the reproducibility of the experiment, and also uncertainties. The first 2 experiments are going to be measuring your walking speed and your jogging speed. You just need to measure a distance and then time how long it takes you to cover that distance at a walking speed and a jogging speed. Then you're going to measure the distance a card is from the floor and time how long it takes to drop it and have it hit the floor. And finally, you're going to have to find either a ball, a marble, a toy car, or something similar that will roll, and then make a ramp out of a piece of card or a textbook and roll it across the card and time how long it takes to go across the desk. You now need to think about what type of equipment would be most suitable. In terms of measuring distance, if it's a short distance, a ruler is fine. For a longer distance, you need to find yourself a tape measure. And in terms of measuring time, a stopwatch will be fine for this practical, although some of the experiments would be better using something like a light gate. Make sure that you try out the practicals first to make sure that your method's suitable, and don't forget to do 3 repeats. Here is an example of the results table that I'd like you to copy down in your books, and then pause the video here while you do the experiment and fill in the results for your 4 experiments. The repeatability of the experiment describes how likely you are if you do the experiment again and again to get the same sets of results. Some of the experiments may have given you a very close set of results, whereas the others may have given you quite a wide spread of results when you did your repeats. I'd like you now to work through questions A, B and C and describe which of the experiments gave you the most repeatable and the least repeatable results, and suggest why in terms of the measurement of the timing. You may, for example, have found that the 3 values that you got for dropping the piece of card were quite spread out and that the results were not very repeatable. Normally we would not measure the speed of a falling object using a stopwatch, and using a light gate would be a much better approach, and this is what they'd ask for in an exam. Repeatability is about how likely you are to get the same results if you do the same experiment again. Reproducibility is the likelihood that someone else doing the same experiment as you would get the same results that you did. We can look at this when we're in class together. We're now going to look at uncertainty. This tells you how reliable your values are. Now, we're just going to try and find the uncertainty of your experiment where you rolled the ball or the car down the little ramp. You will have 3 values for the time taken. And to find the uncertainty, you first of all need to find the range, which is just the difference between the smallest value and the largest value, and then you divide that by 2 for the uncertainty. So in the example, we have 3 values for the time: 8 seconds, 10 seconds and 12 seconds. The difference between the biggest and smallest is 4 seconds. Divide by 2 gives us an uncertainty of 2. Now that we know the uncertainty is 2 seconds, we can calculate the percentage uncertainty to give us an idea of how reliable our results are. If the mean time was 10 seconds and our uncertainty was 2 seconds, then to find out what percentage of the mean time 2 seconds is, we would do 2 divided by 10, which would give us 0.2, and as a decimal, 0.2 can be converted into a percentage by times it by 100, giving us 20%. So our percentage uncertainty is 20%. We're now going to look at converting some units. It's quite common to be asked to change kilometers per hour into meters per second. So here we have 36 kilometers per hour. The first step is to change the kilometers into meters, so we times by 1,000. 36 kilometers is 36,000 meters. Then we need to convert the hours into seconds. There are 3,600 seconds in an hour, so we're going to be dividing by that 3,600 seconds. So times by 1,000, divide by 3,600, and we get 10 meters per second. A horse gallops 44 kilometers per hour. What would this be in meters per second? So work this out by timesing the number by 1,000 to change kilometers into meters, and then divide by 3,600 the number of seconds in an hour. Pause the video while you work it out. The answer should be 12.2 meters per second. You may also need to change miles per hour into meters per second. So 60 miles per hour we would need to times by 1,609, because there are 1,609 meters in a mile. That gives us 96,540 meters, and then again divide by the 3,600 to get the final answer in meters per second. A space shuttle travels at 17,500 miles per hour. What would this be in meters per second? So this time we're timesing by 1,609 to change miles into meters, and then divide by 3,600. Remember to pause the video while you work it out. And hopefully you've got 7,822 meters per second. You may have noticed already that when you go from miles per hour to meters per second, the number that you get just about halves, and this is a good way to check you're making your calculations correctly. Well, that brings us to the end of today's lesson, so I hope you found it interesting, and thank you very much.